Hi everyone, this is Shaukat Reza Chauhan. I am a department of CS. My ID is 17339341. Today I am talking about object counter. What is object counter? Object counter is a device which is designed to count the object which is passing from above it or by touching it. But main work of object counter is the counting of object or things. Who is and where and which purpose we can use this object counter. Object counter are widely used devices. They are used at different places for different purpose and different uses. They can be used as visitor counter, vehicle counter, material or product counter, etc. Following are some of the example where object counter are used. First, in lift, first point, in lift to count and display number of person inside the lift at a particular given time. Another point, in any big supermarket or shopping malls as a visitor counter to keep track of the number of visitors who have visited the mall. Another point, on the conveyor belt in the industry to count number of objects passed. And the last point is in vehicle parking place to count and display number of vehicle inside the parking lot. Thus, the application areas are varied where object counter are used. The object counter is made up of sensor counter and display. Thank you everyone.
Hello, my name is Abir Ahmed Khan. Welcome to our project analysis. So the project we chose was a two-digit object counter. My personal contribution was mainly in working principle and functionality, and lastly in processors used for input and output. So this is the project we have done. This is the working principle and functionality. So at first let's discuss about the places where it can be used. So in our daily life it is used for visitor counter for shops and markets, or vehicle counter for material and products. The basic components of object counter is sensor counter and display. The circuit here can sense object passing by at any time. So this is the picture I'm going to use to describe it. First, this is the infrared LED, which is the main thing that detects any object. At first, we can see if there is no object passing through the photo. There is no change in the photodiode. And the output always stays one, which is high. As long as no object will pass through here, this will always stay same, as the photodiode won't sense anything different, and it will stay always the same. But for when an object will pass, this infrared LED will be reflected through that object, and the photodiode will sense it. And when it will sense it, the output will get 0, which is a low output, and it is then sensed by the photodiode and gives the low output. This low pulse is then given to counter chip through 2 transistors, so the counter increments by 1 digit and displayed on first segment display. So but here we used 2 displays that will give value till 0 to 99. So for this, when count stars, first display increments from the first display increment from 0 to 9. Then when another increment occurs, the first display The first display gives pulse to the second display, and which will increment one digit, and it will make it 10. Then it will start again, and it goes, first display will go back to 0, making it 10. Then first display keeps incrementing till 0 to 9 again, and it goes like a loop till 99. And this is the processor part. For the processor, which includes the input and output section, it basically is same as the functionality and working principles, but all the components names and models are described in this part. So my groupmate who can explain it better in the implementation part. I'll give a brief explanation. So first, the IR LED emits light, and then the object passes through, it gets detected, and the IR transmitter receive the object passing through. Then the 7 segment decoder, and basically it increments the value first, as I said in the working process. So and then the second segment decoder decodes it and makes it manageable for the display to read it. And then the 7 segment display takes the value from the decoder and then displays the count. Whenever one object passes through, it sends to the decoder, and then sends it to the decoder, and then the display shows the value. So this is probably from my part. Thank you.
Hello, I'm Rafid Mohammed from the Department of CSE. My ID is 1632845-3. So far, my contribution in this project was doing the simulation and explaining a bit about the applications of this project. So, the simulation is about a 2-digit up or down counter used as an object or product counter. So I have used a 8089C51 microcontroller with a firmware to get the job done, because all the components were not available and the design was becoming complex to simulate. AT89C51 is a low power high performance CMOS 8-bit microcomputer with 4K bytes of PROM. It works with the 8051 architecture. It's an economical chip which made our project cost effective. This is the microcontroller here. Okay, then let's go straight up to the simulation. So here in the simulation, if I start it, initially the values are set to 0 in the displays. So if I turn this switch on, the switch 1 on, the display shows an increased number. So the number is increased by 1. If I again turn on the switch, it's increased by 1 again, and so forth. Like this, it counts. And if again I turn on this switch, like the switch 2, then the value is decreased. So it's a perfectly functioning up down counter which can be used further as an object or product counter for further applications. So here's the source code I have used. So in the source code, we've declared an array to store the corresponding hex values to further pass them to the display, to the BCD display, and so forth. So let's go to the presentation again. So the software we have used for the simulation is Proteus, and the programming language I used is C. Let's talk about the applications of the project. A 2-digit or 3-digit or anything a up or down counter object counter can be used for real-time counting of the people in an elevator. It can be applied for a conveyor belt too. It can track the number of passing product in a conveyor belt while production in real time. It can be used also in marketplaces or offices, like a get in or out button can be used to track the number of employees in an office or a marketplace, or sensors can be used to keep track how many customers entered the shop. So as the future is coming, a data-driven world, so it can be very useful to keep track of the data. It can be used in a parking lot too, so the count of the cars can be tracked. We can know it's full or not. And the display, we can also display the scores by a counter, by an object counter, like the scoreboards in sports. Thank you. That's it.
Assalamu alaikum, I'm Sabiha Sain. I am going to talk about here drawback and conclusion. Drawback. Whenever two same objects pass at the same time, the object counter considers it only as one single count. Conclusion. Analog electronic components were investigated to a OP-amp, a LDR, a BCD counter, a BCD decoder, and a 7-segment display were combined to form a digital counter circuit. Different methods were analyzed to determine the best technique for creating an efficient counter circuit, and a simple one was chosen and the circuit was designed. The chosen circuit was verified through simulation using Proteus. The design was implemented and modified to suit the needs of the project. Problems were analyzed and repaired when necessary until it was concluded that the circuit had met the design criteria of the project. That's all. Thank you.